Hi there, welcome on Untitled Code channel. Today we will talk about currying functions in JavaScript. So let's imagine that we have a sample. It's a function add, which accepts two parameters. And in result we have 5. So it's the usual function. Just let's comment it. Curried functions, it's another function which is a bit transformed. It will be this one. And result is the same 5. So now we see that usually the task is transform add function into the function which should accept parameters into different parentheses. So what is a curried function? A curried function is a function that takes multiple arguments one at a time. So we have multiple arguments and we pass it just one at a time. Given a function with 3 parameters, for example, the curried version will take one argument and return a function that takes the next argument, which returns a function that takes the third argument. The last function should return the result of applying the function to all of its arguments. So, in our case, let's imagine that we need to implement this function. So how can we do it? First of all, we see that this one is function execution and then is function again. So this function should return function. Okay, let's implement it. Let's call it function a, and it should return function which accepts b. So let's run it, and now we see it's 9. It's expected result. So we have 4 plus 5, it will be 9. So what do we have? We have a function which returns another function, and when we return this function, value of a value is already saved in the closure, and then we can add it to b. Also, we can simplify this function to this one. Let's comment this one. We do not need it anymore, and now we see that it's 10. So using ES6 or ES2020, we transform this function in much more smaller version. So add function receives first argument a, and it returns a function which accepts another parameter b, and then it returns sum of this function. So right now, let's create a curry function. Already we know how to implement curried function. Let's create a function which transforms your add function. So curried doesn't call a function, it just transforms it. So in our case, we don't need it anymore. So we have our function. We have the same add function, and now we will create add function. We will create curry function which will transform this one. And now let's apply this curry function to our add function. So let's call const curried function, and it will be curry of function add. And now we can console log result. Let's run it, and what do we have? We have 8 results. So what do we have in the result? We have curry function which returns a function which accepts a argument, which returns a function which receives b parameter, and in result we apply this function. We'll apply function f for these arguments. So we have add function, and we transform it to another function which accepts each argument one by one. It's a curried function. So, but let's imagine we have another case. We have function with 3 arguments. For example, c. It won't work because we have no third parameter. We can add it here again, but in this case, what we will do if we will have 5, 10, or 100 parameters? We need to implement curried function in a bit more complex general way. So we have the same function, and we need to curry this one. It's a bigger one. So let's create a new general function, curry function. So we need to return a function again, and it will be curried function. Using spread operator, we get all arguments, and now we have two cases. If we already passed all arguments, we can call our function with these arguments, or if we pass just a couple of them, we need to return another function and wait for all other parameters. So let's do it if we have some statement and else. So if, what do we have here? We need to check if arguments length is bigger or the same as can accept the function. So we have such function length. We can call length for function and get a number of possible parameters it can accept. So in function declaration, we have a couple of parameters. Now we have 3 of them, and now we know this number. If we will call function length, we will get this value. So if we have more than described here, or at least the same number, we can execute this, we can apply this function with these parameters. And let's return value. Let's call func, apply. We'll pass context this and arguments. So apply receives array and we pass array. In other case, for example, if we have less than 3 of them, let's return another function. Which waiting for new option of parameters, and it return our curried function. This one, curried function. Apply again this. So what we are doing here? We have array of new parameters, and we call the same function. It's called recursion when we inside the curried function call this function again, and we pass new parameters. We concatenate all parameters with new, and here when we get this function again, we will check this number of parameters, and if it's the same number, we can return function result. So let's try this function. Let's transform our function add. Let's call it curry. And let's try it. Let's try it with 1 and 3, for example. Let's run it. Yes, apply. So we see that we get the function. Function was returned, but in case we will call again the third one, we will get result. It's 7. So it works fine as we expected. Also, we can simplify it just a bit with ES6. So let's try to do it. So we have the same result. Also, we can simplify it a bit more. With the arrow functions. Everything works the same. Let's keep it here, and okay, and let's call it in another bit way. So right now we can call just a part of this function, for example, for first two parameters, and the third one we'll call in another function. So let's imagine this case. And now we have a partial function, and we can try to call it with our new argument, the third one. Let's try it this way. Okay, let's comment. Now we have 10, and also what is important that we can use this function with different arguments. Let's use it for 7, for example, and something else. Let's clear it and let's call. So we see that we have a result of the basement is two first parameters, it's 1 plus 3, and then we can add any other value, and we will call it multiple times and we will get the same result. So how can we use it? Let's imagine some more useful case. So let's imagine that you created a function logger. This function accepts two parameters. It's importance, and message. And just console log. It's a very simple function, and in case we will want to call it, we can call logger warning and some text. Let's run it. So we see that warning and there is some problem, but in case we want to call it a few times in different places, we need to copy that. New problem 2. So we need to copy that, and as you see, we have copy paste this warning. We need to pass warning again and again. So what will happen if we get a function warning, for example, warning function, and it will be carried function from this one logger. So let's try to use curried for this one. Curried log. And now we can create a couple of new functions. It will be function const warning. And the new function error. And now when we will call warning, we need just pass a message. So let's call it. So we see that we have warning function. We passed message of this warning, but also as a result we have our previous function logger with importance and with message. So in this case we can call again warning. We will call it, and we see that message is another, but importance is the same. And in the same way we can call error. And as you see, right now we can call different functions and pass just one part of parameters. It's a message, but importance of this logger will be already saved in closure when we carried this function. It's a very interesting approach. So, and what's important in these functions when we created? When we created warning and error functions, we partially executed logger. So we took a logger and just wrap it. This is called a partial application. So a partial application is a function which has been applied to some but not yet all of its arguments. So right now it's a partial function because it was applied just for importance parameter, but not for message. And then we are using this partial executed function for the last part of parameters, its messages, and then we can execute the whole function logger with all parameters, with importance and with message. Let's show the last example, the most useful you can use in your real world life. Let's clear it. Let's leave just carry function. Okay, let's imagine that we have users with different statuses. So, for example, it may be submitted, rejected, unlocked, or locked. And we need to check every user. So, and we have, for example, a user. So, how can we check this user? Usually we could call, for example, if user status is for example, we want to check if this user is submitted. Is submitted console log submitted. So as we see, it's not true because submitted is 1 and 2 is rejected. Let's change it to 1 and run. So it's submitted. But in our case here, we need pass user status and this user status value. And in case we will check it for all types, it will be 4 times of copy paste. Let's change it and simplify it a bit. We don't need carry function already. Let's create a function which compares statuses. So we will use currying here in this way. So we have a function which compares statuses. We pass status A and status B and then just check are they the same. And we have this function, and just let's update this function with ES6. And we will return is it the same. And now, based on this information, we can create a couple different functions to check is user submitted, is user rejected or not. Okay, let's create a function is submitted, for example. So it compares statuses and we pass user status submitted. And as a result, we will have a function is submitted. And let's copy this result and let's re-implement this if statement. So if is submitted, let's run it. So it was called we need pass user status. So let's clear it. And here we see that it was executed, but as you see, result if statement looks absolutely in another way. And for example, we need a few times, we need to repeat it a few times. Also, what we can do, we can okay, let's implement function for all cases. So we have is rejected, is under moderation, unlocked, and is locked. So we need just compare statuses, and now we can use it as much as we want. For example, is rejected, is under moderation, is locked, we don't use it. So what do we see here? Right now this code looks much more better and readable. From clean code perspective, it's the much better solution, because here we can read and understand what do we need. So we check if is submitted user, we can do something. In the previous case, we need to check if user status is some status somewhere, some constant. It's not a good solution from a clean code perspective, but this solution, it looks much better. So we could implement it using curried. So curried helps us to compare these statuses, and it's one of the possible real-life examples how you can use these curried functions. And that's it from my side. Thank you for watching. Subscribe to this channel, and soon there will be new videos about functional programming in JavaScript.